Hello, Algebra 1. We're going to look at another type of rule for sequences called an explicit rule. So here's today's big idea. Given the sequence 10, 15, 20, 25, and 30, I want to find the 100th term. First, is this an arithmetic or geometric sequence? Well, I can see that to go from 10 to 15, 15 to 20, 20 to 25, and 25 to 30, we are always adding 5. Because this is an addition pattern, hopefully you all can tell that this is an arithmetic sequence. We can write the recursive rule for this very easily. F of n equals f of n minus 1, the previous term, plus 5, when our first term equals 10. So using the recursive rule, which term do we need to know in order to find the 100th term? Well, it's always the one before, so we must find the 99th term. That is going to take us forever, okay? So we definitely don't want to do that. There must be a more efficient way. When I talk about efficiency, that means it's a faster, easier, quicker, better way. So let's take a look at this. Recursive rules are easy if you know the term before and the rule automatically, and the common difference or common ratio, but I don't want to list 99 numbers out. That would take forever. So we're going to find a more efficient way. Today we're going to look at the arithmetic side, and tomorrow we will look at the geometric side. So here's our sequence again, 10, 15, 20, 25, and 30, completing the table. So here we go. So term number, the first term that we have is 10. The second term we have is 15. I'm listing them out, 20, 25, and 30. Okay, so the next thing is how many times do we add 5? Well, because it's our starting value, I don't add 5 at all. But from here, I add 5 one time. From here, I go 1, 2, I add 5 twice. To get here from the original, I add 5 3 times, and to get here from the original, I add 5 4 times. So it's the number of times we add 5. So if you notice, the number of times we add 5, well, this is what I'm going to be looking at right here. So let me erase this piece. We're going to look at the difference between the 0 and the 1, the 1 and the 2, the 2 and the 3, the 3 and the 4, and the 4 and the 5. If you notice, all of those numbers are 1 less than our n value, okay? So this is going to be n minus 1. We're adding 5 n minus 1 times. So what do you notice about the number of times we add 5? Well, it's always 1 less than the term number. So if I want the 100th term, I need to add 5 99 times. When you add something over and over and over again, you can actually multiply it. So let's go ahead and look at this. Here is an explicit rule for an arithmetic sequence. Notice, we don't have to know the term before. So we write nth term equals the first term, it's where you start, plus the common difference n minus 1 times. So we're adding 5, 1 less than our term number. So if I want the 100th term, I need to have my start, which is 10, and I need to add 5 99 times. That's what that means. So let's circle back to today's big idea. So given this sequence 10, 15, 20, 25, and 30, we're going to find the 100th term. We know that f of 1, our first term, is 10. I also know that d, our common difference, is 5. So for our explicit rule, I have the first term plus the common difference n minus 1. Notice I don't have fn minus 1, okay? That is the term before. This is just n minus 1. But remember, n is our 100th term. This right here, n equals 100. So what that means is I'm going to put 100 in for n. So I have 10 plus 5 times 100 minus 1. So I have 10 plus 5 times 99. I'm adding 5 99 times. If you do this in the calculator, we're going to get 505. So that is what f of 100 is. The same sequence can be described with a recursive and an explicit rule, true or false. Well, we know that we can describe this sequence as a recursive and an explicit rule because here is the explicit rule right here. And then if we go up top, we wrote the recursive rule up here. So we do know for a fact that this is a true statement. You can write it in both ways. Let's take a look at some more examples. So we're going to focus on arithmetic today. So if I go, I see 2 is my first term. And I also see plus 11, plus 11. This is the same. These will look familiar because they're from our arithmetic recursive notes. So our common difference is 11. So when we look at this, we know that the explicit rule is written like this. The nth term equals the first term plus the common difference n minus 1 times. So to write this rule, I have f of n. The first term is f of 1, which we know our first term is 2, plus the common difference, which is 11, n minus 1 times. We don't need to write when the first term is such and such because we have it right here. Let's take a look at another one. So we know for a fact that 5 is our first term. And we add 2 every time. So our common difference is 2. When we write our formula, we have f of n equals the first term, 5, plus 2, n minus 1 times. 1 less than whatever number we're looking for. In our table, we have the same thing where we have 29 is our first term. And then every time we are subtracting 5. Remember, in an arithmetic sequence, your common difference could be a negative number. So to write our rule, we have f of n equals our starting value of 29 plus the common difference minus 5 n minus 1 times. Once again, we have our first term of 44. And then we add 11 every time. And so our common difference is 11. So we have f of n equals our first term, 44, and we're adding 11 n minus 1 times. So if the 80th term, we're adding 11 79 times. So looking at this one, find the first 5 terms of the arithmetic sequence. Here's the explicit rule. So I know that the first term is 3. I know that that's the first term. I also know that the 6 is the common difference. Or the D value. Okay, so when we find we're going to list the numbers first. So I know if I start listing them, 1, 2, 3, 4, 5, I'm going to start with my 3, and I'm going to add 6. So plus 6 is 9, plus 6, plus 6, plus 6. I want to find the 12th term, but I don't want to list everything out. So I'm just going to plug it into the formula. So I have f of something equals 3 plus 6 times something minus 1. Well, that something is, I want the 12th number. So I have 3 plus 6 times 11. So I'm adding 6 11 times to 3. So I have 3 plus 66, and that's going to give me 69 as the 12th term. When I find the 29th term of the sequence, nobody wants to do that by hand. So I have f of something is 3 plus 6 times something minus 1. I want the 29th term, so I'm going to have to add 6 28 times, 1 less. So I have 3 plus 6 times 28, and I know that if I use my calculator, I get 171. I'm going to go ahead and stop there, and I hope you have a great day.